Okay, here we are to note card 9, derivative of the function. And so this is a difference quotient. And this is the thing that everybody in this class needs to know. Maybe this could be another t-shirt, I don't know. You think that'd be a good t-shirt right here?
I think that'd be a great t-shirt.
I think it would be. Then we got to do some, anyway, so we'll have to see about it because that's pretty nerdy. So that would be pretty good for a t-shirt. But it's this whole thing. So what I want to do is I want to just okay, f of x equals x squared plus 3x. I want you to find f prime of x.
On like a separate piece of paper.
You can do a separate piece of paper, or if you have room on a paper somewhere. You need to borrow paper anywhere, Hannah, you need paper.
So we're starting on the front now, or
I'm kind of, partially I'm trying to see what kind of connection you have in your mind with what we just have covered these last couple of days and even just now.
you come to senior night?
Pardon me?
You come to senior night?
What, when is,
On Friday?
oh, senior night Friday? Is that at the football game?
Mm-hmm.
I plan to be there, right?
You want me to put you in my speech?
If they let me in, right? If you won't say too many bad things about me.
To Mr. G.
To Mr. G, just kind of limit how many bad things you say. You only say 2 bad things about me, then I'll
Just 2?
come.
Okay.
Yeah.
I'll have to figure out which one.
You have to cut things out.
Yeah.
Don't only 2. All right.
Mr. G. These are my new Crocs.
Oh, other new ones?
Yeah.
Oh, man.
Ah, poopity-doo.
Oh, did I do something wrong? Never mind. Not them.
And so this is how you could set this up. Is that how you pretty much did it?
Yes, and I thought it was wrong.
But you were right? All right, very good. And so if you had the reaction to do this, how did you just start writing this stuff down? Aaron, did you write this down? Did you just start writing this down when I put it up there? You did too? So what about you, Hannah? Did you have that reflex also? Do this? Okay, very good. That's really good. You guys are good. And then we can just expand it. Hannah's right. So we have x squared plus 2xh plus h squared plus 3x plus 3h and then minus x squared minus 3x. Is that right?
Yes.
And then we go ahead like this and we divide by h and then gonzo, 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 gonzo.
I like that, Mr. G.
So, limit, I just made it up, I don't know.
I like that, though. Gonzo.
This one gave a picture.
2xh
You have a pet turtle?
plus h squared
I want a pet turtle. So
plus 3h over h.
The H is large.
And so we have equals limit as h approaches 0, and we have 2xh over h, so that's just going to be 2x, right?
Yes.
So we got 2x plus h plus 3, right? And we substitute in 0, we get 2x plus 3. How many of you geniuses came up with that? Man, that is awesome. You just feel good. Okay, very good. Let me go ahead and let's go to this next section, which I want to look at, which is derivatives in disguise. And so it says, identify f of x, then evaluate each limit. I don't want to do all of these. I just want to identify f of x in these. Okay. On this number 1, what is f of x equal to?
2x.
2x to the 5th. Okay.
Oh, yeah, that's it.
Right? And we know that if you keep in mind what the format is when you have f of x plus h minus f of x, what you have to do is look at the last thing here, because that's where you're really going to find what f of x is, okay? When you look at the derivatives in disguise. And we're not going to go through all these, and so, but this one here, what is f of x going to be for this one?
6x cubed minus 4x.
Yeah, it's going to be 6x cubed minus 4x. Okay. Now, how did...
Switch the signs. Want to do it that way? Like you make the 6 positive and make 1 negative, and you just kind of switch the signs.
Yeah,
Unless
so...
if it was in parentheses, that's, but since it's not, it's already.
So what you have is minus here, but you're subtracting. So it's like so you have to subtract f of x, right? And when you're subtracting f of x, you're going to get, for this to be positive, then this would have to be negative here. And this is negative here, so that would have to be positive here. So that's really it. Okay.
Smile, Carson.
Okay.
Well, you don't want to picture me?
Picture
Andrew?
snapping
Yeah,
with
that's-
impunity.
Wow. Let me be like this.
Okay, good job.
I targeted it.
Because you're cute.
Let's go on up.
Isn't that cheesy?
So this one here, what is our f of x going to be for this one? This one here should be a little easier. Yeah, 2x to the 5th power minus 3.
Since it's in parentheses.
Yeah, so this one here, if you could identify it like this or put it in this kind of form, that could make things easier for you. It'd be like if we took this last one here and we rewrote this as 6x cubed and minus 4x. So that would make it be this, and so this is going to be what our f of x is going to be, okay? So just little tricks for finding what's what. And then this one here, what are you going to have for this one here?
Oh, that's. We'd have 7. And then, what's that, cube root?
That's a cube root.
X squared,
Minus 3.
and then minus 3.
Yeah, that's what it would be. And it wouldn't be the limit, it'd be f of x equals this. F of x equals that. Okay,
Here's another Hannah.
all right.
And you say they suck at that.
Yeah, I didn't understand.
Okay, I won't,
I guess that is your name, isn't it?
Yeah, it is.
all right, guys.
It's all my handwriting.
Exactly.
Okay, these are exercises in recognizing derivative here.
So we're just finding the f of x again?
Yeah, well, here's what I want to do, and you could this is f prime of x for f of x equals
3x squared.
3x squared, yeah. 3x squared. Okay, and then it's gonna, f of x is gonna be this thing, right? All this thing right here will be our, in fact, I want to do it like this. That's where that is, okay?
So for number 3, would it be 2 over x?
Yeah.
Yeah, yep, 2 over x, very good. Or, how could you say this instead? How can you write this instead of 2 over x? How can you write this instead?
It's like 2x to like the negative 1.
Yeah, that would be it.
Good job, Aaron.
Good job.
Thanks,
Good job.
Hannah.
And actually, that's going to be helpful for what we're going to be doing. And so I want to just, this one here, you can see what this is, I hope. What is f of x here?
Negative x to the minus 2. Minus tray.
There we go. And since you subtracted, it would have just flipped these signs for these to be positive, these have to be negative.
Do you start with like the square, and that's why you didn't include 3? Include second things? Like the 3 in front of the x to the power?
Oh, here?
Yeah, do you,
Yeah, this is a constant term, so there's no x with that at all.
so you always start with the x when it comes to?
Yeah, because what it is that these 3 terms here match up with these 3 terms here.
Okay, got it.
But you'd have to for all these to be positive, you would have had to have the value of the function be negative, and you see the negatives up here, don't you?
Yes.
So just kind of pay attention to the signs, and then you'll be all right. Okay. Okay, I don't want to do that one. I don't want to do that one. I don't want to do that one. And definition of derivative, we sort of played with these last Friday, I think, a little bit,
Yeah, we did.
and did things like that. And so we're going to, what I want to do for this is go to the, I want to just go to these algebra review for derivative rules. Do you see this here?
Yes.
Basically, what this is you're trying to go on these exercises and go from radical form to what is rational form. Because this is a really big skill, Hannah, for what we're doing in calculus next, okay? And just do these really quickly. Okay, for number 1, what did you get? X to the 4/3 power, okay? Yep, good. And then 2 would be x to the 5/2.
Oh, it's the 2 right there.
Yeah, and then that's the thing. If you just see without a script there.
Because
Yeah,
I understand, I just overlooked it.
yeah,
With
3/5. And lastly,
2/9.
x to 2/9. Okay, good. Very good. Good work. And then we'll go ahead to these ones here. And now we're taking a rational form and putting it back into radical form. And so to put this in radical form, what is this going to be?
X squared.
Something like this. Now, one thing, there's a little bit of ambiguity on these things because you can write it like that. There's another way to do it too.
Mr. G,
I was waiting patiently.
Yes.
I was going to ask my instruction.
Okay.
Thank you. I was waiting patiently, I'm sorry.
I don't know if you were gonna ask a question about this or not.
Okay, so you can also write it like this too. These are equivalent things, okay?
Which one, or do you like prefer either one or?
Well, the thing about it is, it's sort of like, if it's just a single variable, this might be the easiest way to do it. If it's a expression that's bigger than that, you'd have to wrap that inside parentheses. So, I don't know, maybe this way if you can do it, but that's really not as important. And then over here, you're gonna get okay, yeah, that's what that would be, okay. And then over here, you'd get number 7, you get, what do you think for number 7?
It'll be, the 11 always likes everything. I don't know how to say that.
So that would be number 11, right? And then this one here should be pretty easy, right? So you get like 5th, x to the 6th.
I wrote the 6 before the extra, then.
Oh, really? Yeah. Yeah, it's easy to do.
I was just writing that.
But what it is, it's just a matter of getting the practice at it.
Yeah.
This
I
is
feel like I've done
not-
this before.
Yeah. And I think, I'm not sure, I think in pre-calculus last year, we might have briefly addressed this.
Yeah.
I think we did this very briefly last year. What about you? Are you following along pretty well,
Yeah.
Hannah? Got this pretty well? Okay. Okay, then we have these things here. And what it is you're writing all variables in the numerator. And so how do we write this thing here with the variables in the numerator?
The X and everything.
Yeah, x to the negative 5th. Okay, that's good. This one here,
Would you multiply the thing? It'd be 3 over
so you have 3 over 2, x to the
2.
negative 4. We would have here 15 x to the negative 2/3. And if we radicalize this, what would we get? We get 15 cube root of x to the negative 2 power, right? So, and then this one here, you'd get, what is that going to be? 7/4 x to the
X to the
Negative 3/5.
negative 3/5. Okay, yeah. Okay. So anyway, just some things, because we're going to have to, and what we're going to be doing shortly, sort of manipulate between radical and rational form to do what we're doing next, which is really derivative rules. Okay, this is the big deal right here today. And the biggest thing we have, in fact, is sort of the go-to thing that's going to help you more than anything else, is this thing right here. Everything we've been doing the last 3 days, we'll be able to do in a flash with this thing right here. All right? It's called the power rule. They're also, these other rules are also important. The derivative of c, and c being a constant. If you have the derivative of a constant, that is 0. Okay? So anything that is a number unattached to a variable, that would be 0. The constant multiple rule, if you take the derivative, and by the way, this d dx means the derivative of. Okay, we saw the f prime of x, right? So f prime of x, but ddx, when you have ddx before something, means the derivative of. Well, if you have the derivative of a constant times f of x, that's going to be the constant, so it's like you can bring the constant outside of f prime of x. And the sum and difference rule, if you have the derivative of u plus or minus v, that's going to be the derivative of u plus or minus the derivative of v. Okay, so just some things. But this one right here, this is the one that shortly you're going to be saying, why didn't you tell this to me 3 days ago? I'm going to hear that from you, I'm sure. But that's fine. Okay, so here, if f prime of x equals x to the 3/2, then f prime of x, what you do is you take this exponent, x, it's x to the power of 3/2, right? So what we have, this is going to be 3/2. So you take that exponent times x to the 3/2 power minus 1. And what is 3/2 minus 1?
1/2.
1/2. So you have x to the 1/2 power, and then that's what this is. And then you can further, if you, not that you have to, it just makes things easier, we can rewrite this as, what is x to the 1/2 power?
Square root.
Square root of x. So now we have f prime of x, and now we're trying to find f prime of 3. So f prime of 4, I said 3, 4 equals 3/2 times the square root of 4, which equals 3. Okay? Because you got 2 divided by 2. All right? So that's called the power rule, and what that does is it just makes a lot simpler work of the definition of derivative. So you'll be able to short circuit that most of the time. Any questions about this? Do you see how it's helpful to be able to go between radical and rational forms here? Okay, let's go on here to differentiate each function. I want you to look at number 3 first. Go look at number 3 first. 2 has a little complexity. Did you figure it out? No? Didn't figure it out? Okay, let me show you. Okay, number 3, we're going to find the derivative, so that's going to be a prime of t is equal to negative, and we take this 4 t to the 4 minus 1, and we divide that by 2, right? So we took this thing here, 4, plunk it out front, and so we have that, and then for this next one, we're going to have this 3 coming right here, right? Times 3t to the power of 3 minus 1. And then the last one we have is minus, now we have t to the power of 1. So there's nothing needed there. 2t to the 1 minus 1. And then we can simplify everything out. What's this going to simplify to here?
Negative 2.
Negative 2 t to the
3.
third power plus
Negative 9.
9
Squared.
t
T squared.
squared. And this last one is going to be
Just minus 2.
minus 2. Okay? And what happens is if you have to the single power, it, like this one here, it just becomes the coefficient because you have t to the 0 power is equal to 1. Okay? So that's what it looks like, and this is really in lieu of doing the definition of derivative. So that's what this one's going to be. So I want you to go look at number 2 to work out the derivative of that. F prime. Probably want to change this to rational form first. Just doing the rewrite here. So you rewrite into what I call calculus friendly form. This is going to be x to what power? Negative 2/3, right? Okay. Now we can do the f prime of x. And what do we do with this negative 2/3? Comes out front. Times 1/2. Then we have x to the, what's going to be negative 2/3 minus 1?
Negative 5/3.
Negative 5/3. Is that right? Yeah, that is right. So then we just go ahead and simplify this. And that looks like
Negative 1/3.
negative 1/3 x to the negative 5/3. And then you can write that as negative 1 over 3 third root of x to the 5th. Okay? One thing you'll see a lot in this course, for some reason, this square root thing, find the derivative of a square root of x, you'll see that a lot. So you kind of get used to the patterns of the way things look like on those. Oh, okay, finished with that? All right, good. Good job, good job. Okay.
What's your picture? I saw you.
So, well, I want you to go ahead and do number 4. And that may be kind of where we end up with class today.
I saw you
So we're just finding the derivative of this?
Yeah, d dx, that's the derivative of. So you can say f prime of x, or if it just says d dx, you find the derivative of that expression. But for this one, I would rewrite this one in with the variable in the numerator, because then it becomes what we call calculus-friendly form. Now, you might think that calculus is never friendly. Who thinks calculus is not friendly? Yeah, Carson.
I'm seeing all this.
Everyone agrees, they're just working.
They're just working, being the diligent students.
Hey, I'm still here though.
Yeah, that's right.
Oh, no, okay.
So this is my
Whoa, calm down.
this is my calculus-friendly version so far. And now, to go ahead and work this out, equals, we have -3 times x to the -3 minus 1, which is
-4.
-4, minus, we have -1, x to the
Oh, that's, -2.
-2 plus 2x, okay? And then we just simplify from here, so that's going to be equal to -3 over x to the 4th power, plus, those pluses cancel each other, 1 over x squared plus 2x. All right? So that's going to be it. Did you get the same thing there? Pretty well. So we'll see if there's something else. There's a good bit of exercise I'm going to give to you, but I think we're just going to go to this point tomorrow. We're going to go to slide 148 tomorrow. And that's it. Okay, Gavin and Maddie, you need to watch this.
Damn it, Maddie!
Gavin and Maddie.